y equals cosine of 2/3 x. So, the amplitude is still 1, correct?
Yes.
Okay, so let's talk about the period, because this is where people tend to get lost. The period is 2 pi divided by b. So it's 2 pi divided by 2/3, which is really 2 pi times the reciprocal. So if you divide by a fraction, you multiply by the reciprocal. Now, a couple of ways you could do this. You could go ahead and reduce the 2's and you'll see that that's 3 pi. Or you could just multiply top times top, bottom times bottom, and that will give you 3 pi. So that's how you find your period. So that's going to affect the x or y values of our table.
X.
The x values. Yeah, the b value affects the x values of your table. So we'll make a table, starting at 0 on the x's, skipping 3 spots, and landing on 3 pi. So this is where things start to get a little tricky. Halfway between 0 and 3 is 3 over 2. So this is 3 pi over 2. And halfway between 0 and 3/2 is
0.75.
fourths.
3/4.
How do you take half of a half?
Fourth.
It's a fourth, yeah, you multiply it, yeah. So 3/2 times another half is 3/4. So this is 3 pi over 4. And then this is the one that causes the trouble right here. If people are going to miss something on a trig graph, it's going to be that fourth value right there. So here's how you find it. Ready? Did you guys have any trouble finding this one?
Yes.
What I got?
No.
Okay, well anyway, so let's pretend that we didn't. Okay, let's just start there. And I will teach you a trick for this one. The first value is always the period over 4. That's always your first value. Always. That's your first value, the period over 4. So if our first one is the period divided by 4, which is 3 pi over 4, that also is how many steps up it goes each time. So the first one is 3 pi over 4. The second one is 3 more than that, which is 6 pi over 4. The next one is 9 pi over 4. And the last one would be 12 pi over 4. So if you look at those and you reduce those, that's what's on our table over here. There's 3 pi over 4, 6 pi over 4 reduces, so this should be 9 pi over 4. So if you have trouble finding that one, you just take it and divide it equally into 4s there. So 9 pi over 4, and then 12 pi over 4 reduces to 3 pi. All right, now we just have to find the first 2 values so we can complete our table. Well, if I multiply 2/3 by 0, I'm still at
0.
And the cosine of 0 is still
0.
no.
1.
Oh my.
The cosine of 0 is 1. All right.
I thought we were
Now
outside.
let's look at cosine of 2/3 times 3 pi over 4. Well, that reduces to 2 pi over 4, which reduces to pi over 2. And that's what should happen. It should go back to your quadrantals. And the cosine of pi over 2 is 0. And we should have known that because every other one should be 0. So we have 1, 0, negative 1, 0, 1. So you just alternate off. So making this a fraction less than 1, did it make my period longer or shorter?
Longer.
Longer, yeah. So it changed it from 2 pi to 3 pi, which is kind of interesting. And then you just kind of graph it. Do you guys want to see me graph that one? Yes?
Sure.
Sure. I'm just going to do one period, okay? So we'll let this be 3 pi. This could be, this is gross, 3 pi over 2. And this can be 3 pi over 4. And that can be 9 pi over 4. And I kind of cheat. I'm supposed to tell y'all, like, I don't know, like, to put other numbers besides just the ones that are in your table on so you'll know where they are, but I don't really care. And I don't want to. You know, like, I'm just a terrible grapher. So I typically just throw the ones I have on and call it a day. So we have 0, 1. Then it goes to 0, then it goes to negative 1, then it goes to 0 again, and then it goes back to positive 1. That's the graph of y equals cosine of 2/3 x.
What does that mean?
So now we want to graph y equals negative 2 sine of 3x. What's my amplitude?
-2.
No.
Positive
2.
2. JK.
Positive 2. Yeah, remember that the amplitude is the absolute value. So A is negative 2. But the amplitude is the absolute value of that. So positive 2. The period is the part that's really annoying here.
2 pi over 3.
Period's 2 pi over 3. And that causes trouble because it's not an integer, so it's hard to go in by halves. So 2 pi over 3. So we build our table. We have 0, 2 pi over 3. What's half of 2/3?
1/3.
1/3, very good. So halfway between is 1/3 pi. And what's half of a third?
A 6.
A 6.
That's fine.
So once you can find that one, you realize how much are we going up each time?
A third.
A 6. We're going up a 6. Yeah, so it goes from 0 to 1/6. So it's going up 1/6 each time. So that would be 1/6, 2/6, 3/6, 4/6. So 3/6 reduces to
Pi over 2.
One
pi over
half.
2. Yeah. So if you ever get stuck, you can always use this trick. The period over 4, which in this case is 2 pi over 3. If I divide by 4, it's the same as multiplying by a fourth. And that's how you know that you're going up 1/6 each time. Okay? Or I usually do okay with this one. This one is the one that I can't always, it takes me a while to find. But I found that I usually just start counting 1/6, 2/6, 3/6, 4/6.
Do you ever look at like the degree measure in correlation to the radian measure? Like, does that ever help you?
No,
So, like-
I don't even like to think about
Okay.
it.
Because I'm like,
that's way
that's
too
what
much.
I just was wondering.
Well, because okay. Some of them aren't on the unit circle. So like when you say like, I don't know, what if it were 3 pi over 5? You know, so that would cause trouble. So far all we've looked at are,
Unit circle.
but yeah, the x values are always on the unit circle.
Okay.
When we plug them in, it goes to something on the unit circle. But I don't ever think about it that way.
Okay. I'm
Okay.
just curious.
So at this point, I'm going to plug in 0, and I have y equals negative 2 times sine of 3 times 0. Well, the sine of 0 is 0. And you may as well go ahead and memorize that. Sine always starts at 0, 0. Then, do I even need to plug the next one in, or could you tell me what that's going to be?
That is what?
No, it's going to be 2.
It's either going to be 2 or negative 2. Which one?
It's gonna be negative 2.
It is going to be negative 2. Yeah, it rotates through A first, and so A is negative 2. And here's why. Y equals negative 2. So we have y equals negative 2 sine of 3 times pi over 6. Well, what is 3 times pi over 6?
1/2.
Half pi, right? Well, the sine of half pi is 1, and so negative 2 times 1 is negative 2. So it does go to negative 2 here. All right?
Cool.
Yep. And then you can just rotate out from there. 0, positive 2, 0. Make sense? Okay. Now, I'm not going to graph. Do I have to graph this one, or are you guys good?
No,
It's just going to be
good.
really
Good.
small period. Are y'all okay with that?
Yes.
Because I would rather take a moment and just explain something to you. So let me pause for a minute. Let me get a clean slide up here, and I want to just talk you through what we've kind of learned and put together so far.
Okay.
Okay, so what we know so far is that to find the amplitude, we take the absolute value of A, and to find the period, we take 2 pi and divide it by B. And then for sine graphs, here's what we have figured out. You may not know it yet, but you're about to. You may not have realized it. This will be 0. We'll skip 3 spaces. This will be the period. That didn't look pretty. Okay. Then these we know how to fill in. Over here, sine graphs always start at 0. Then they go to whatever their A value is. 0 again, then the opposite of A, and then 0 again.
Okay.
That's true for if you build your table the way I told you to, that's true for every sign graph. 0A, 0, negative A, 0. So you can run those off real fast without doing a lot of plugging in and computation, and it's just a pattern-oriented thing. Cosine, on the other hand, when we build his table, doesn't start at 0, 0, it starts at 0, comma, normally 1, but that's only if A is 1. So let's not put 0, 1, let's put 0A here. It'll start at A. And then it goes 0, then it goes opposite of A, then it goes 0 again, and then it goes back to A. So if you learn that, and I know it seems like a lot to learn, but you'll do so many of them in the homework that it won't be so bad. If you learn that, like, this will make it so much easier for you to evaluate these. And we have one more after this. So I'll give you a minute to jot that down. We're going to do one more, and then you guys can work on the problem over here. Okay, so for this example, the final example, I've given you the graph of an equation, and I want a graph of a trig function, and I want you to come up with the equation. So we know that it's a cosine graph because it doesn't go through the origin. So we know that it has to be y equals a cosine bx. So all we have to do is figure out what a and b are. Well, we can look at the graph and we can see that it goes through the point 0, negative 2 first, which means that the a value must be negative 2. So that just leaves us wondering, well, what's the b value? And here's how you figure that out. It'll work every time you're trying to solve for this. I know that the period of this graph, I can look at it and tell. The period is what? 4 pi. It does one complete, there's half of an up, and then there's half of a trough, there's a whole crest, and then there's another half of the trough. So that's, one full trough, one full crest, and that means that's one period between 0 and 4 pi. Okay? So 4 pi is your period, and we know the formula for that is 2 pi divided by b. Well, if we cross multiply here and solve that for b, that gives you 4 pi b equals 2 pi. Well, if I divide both sides by 4 pi, that's 2 pi over 4 pi, which equals 1/2. And so, you could probably look at that and figure out it either had to be 2 or 1/2. You just have to be careful about which one it is. So a lot of people could do that without figuring it, but I found if I ever get stuck, I can find b over there like that. Just take the period instead of equal to 2 pi over b and solve for b. So y equals negative 2 cosine of 1/2 x. And that wraps up section 4.1. Yay!